Hello and welcome to GopherCon, Lightning Talks Day 2. It's so great to be here. Uh, I hope you enjoyed yesterday's Lightning Talks as much as I did. Like I said yesterday, this is such an honor and a privilege for me to be able to bring up these new voices and these new great ideas uh, to all of you live as we're out there in the world. This is so much fun. I wish we could be together in person as always, but unfortunately, these are the times we live in, and hopefully next year we all can do. But anyway, we have an incredible slate of speakers for you today. And I know I said that yesterday, and I hope I delivered. And today I mean it again. Um, awesome speakers coming to us from around the world. We have so much to get to. Before we do that, though, let's go over the rules of the games for all of our contestants. Each one of our speakers will have exactly 7 minutes to give their talk. That's right, 7 minutes. At the 1 minute mark, if they have not if they're still going, they will hear this sound. Wonderful. And if they go over their time, the curtains will literally close on them like this. There we go. So there we go. Those are the rules of our games. Unfortunately, we don't have the big hook like we usually do in person to pull people off stage, but we have the curtains, and that's good enough. So with that said, let's start the show because you don't want to hear me speak. You want to hear these amazing speakers. So we're going to bring up our very first speaker of the day joining us here. Amit, are you with us?
Yeah. Hey, hi. How are you?
Good. And yourself?
Yeah, I'm doing good. Can't complain. It's raining here in LA.
Oh, you're in LA right now. So there you go.
Yeah.
That answered the question of where you're joining us from. It's an unusual event to have that rain in LA. So
Yeah.
try and enjoy it. Go sing in it later. I hear that's fun.
Yeah. I see.
So with that said, Amit, why don't you take it away? Love to hear from you.
Yeah, sure. Hello, everyone. This is Amit Misra here. Today, I'm going to talk about some patterns which we found useful while building our replay platform. Let's go over motivation behind this talk. Basically, here at Fox, my team and me are responsible for building a platform or taking care of the platform which helps to serve live and VOD contents to millions of concurrent users. And as you guys know, like serving live content has its own challenges because of the unpredictable nature of the traffic and overall audience itself. And our platform basically helps to serve events like Super Bowl, WWE, pay-per-view fights, and various Fox entertainment related shows. In order to basically handle various challenges, we planned to rebuild our whole platform using Golang. And the reason behind was it was like because our legacy Node.js based platform was very tightly coupled application, and it was very hard to scale. And it had very high dependency on its external services without any fail forward strategy or caching kind of strategy. But due to simplicity of the Golang and power of concurrency, we are in process of migrating our whole platform into Golang, and we are already seeing some good results. Um, and based on those good results, we discovered a couple of patterns which are very easy to implement in Golang, and I wanted to share with you all. Um, Agenda. Well, let's talk. Let's dive into first pattern. The first pattern is like thinking about a true microservices. Since we had this whole monolithic system, we had 20 to 30 internal, Node.js modules. We wanted to come up with a strategy where we can divide these services into true microservices, and we basically came up with a strategy of dividing those into using three different criteria. The first one is like, okay, what are your dependency on the external services? Second one, like, okay, even if we had the legacy services and we could not migrate those into Golang, how do we deal with those? So we probably build a Golang based proxy on around those kind of services. So that was our second criteria. The third and the very common criteria which we use normally is like, building the services based on dedicated data stores like Elasticsearch or DynamoDB or, anything else which is suitable for your project. The second pattern was like a strategy to migrate the legacy services itself. Like since we decided to build all these services into Golang, but we cannot just go. We could not just migrate those and one shot. We could not afford any kind of downtime. So we had to come up with some kind of a strategy where we can still build these services and go live with these services without any downtime. And this is how we started. We had this start state where we had a legacy kind of playback services, which was serving to the clients. The first thing we started doing is like start building the proxy services around those legacy services, and these proxy services were based on the Golang. And you will be surprised to hear that just by putting the Golang proxy gave us so much performance boost without doing any optimization. These proxies were just taking the same request and response; it was just passing to the client, but that itself gave us good flexibility. And the second step we followed was like, okay, once we had the proxy, we started swapping out our legacy playback services using new Golang based playback services, and we started doing some comparative testing. And once we had some good confidence on the comparative testing, we basically implemented a feature flag, and which we can turn on, turn off based on what we needed. And then once we had that whole thing implemented, we could just rely on our new playback services, which was based on the Golang. That was very pretty much a useful pattern we've found ourselves using in all over the stack. So hopefully it will be useful for you guys too. The third pattern, and the most important pattern, was the circuit breaker pattern. Basically, circuit breaker pattern and microservice word, you might know that it's very common pattern, which basically allows to build you fault tolerant and resilience kind of services which can survive graceful degradation. The purpose of the circuit breaker pattern is basically is to detect the availability of the underlying services which caller services are depending on, or any kind of service failure. And we in order to implement these services, we basically use Golang, because implementing this kind of pattern was very simple in Golang. And one of the thing we used was like the Hystrix Golang library, which is of course based on the Netflix Hystrix. But this is how our configuration looked like, which had various control over, like a maximum concurrency, timeout, and all those kind of things. And based on the circuit breaker pattern, we could implement our monitoring dashboard, which was which gave us like a clear view about, okay, what's going on with our external services, which previously we were not able to control. But now we are able to understand that if those are responding slow or what's going on. And based on that, we could open and close the circuit, and serve the fall of fail forward kind of scenarios, or forward kind of responses. The fourth pattern was like the strategic caching. Since I explained that during the live environment, caching contents is very hard. And for that, we had to come up with a good strategic, good caching system. And we built our whole caching system using Golang. And it's one of the most performing platform in our whole system. And the Golang provided us the flexibility to build the features like leaky bucket cache, where the kind of like keep or cache warm, and the similarly stale cache. The fifth pattern was the single flight pattern. In single flight pattern, you will find this is the most useful pattern when you're trying to deal with the thundering heart kind of problem. It basically helps you to suppress all the duplicate function calls, and we use this Golang single flight. And here are the results we could achieve. We have infinitely scalable platform, and this is how it looked like. Previously, our Node.js response was like way more than what we have in Golang. And similarly, we could save lots of cost, and we are able to serve our current NFL event which is going on, and hopefully we are going to planning for the 2023 Super Bowl. This is our roadmap looks like for the Super Bowl. Like, we are planning to serve at least 20 millions of concurrent users, and then moving everything into Golang. And then
Well, thank you, Amit. That was a wonderful talk. And good luck in the Super Bowl. I know I'm rooting for the Red Sox to win the Super Bowl this year. They're amazing skaters. Anyway, let's bring up our next speaker, Asdine. Are you there?
Yes, I'm there. Hi, how are you?
Uh, Good, and yourself? Where are you coming to us from?
I'm on holidays in India right now.
India. Nice. Must be getting late there.
Yeah.
I can only imagine. Well, I'm not going to keep you up too much longer. Why don't you take it away so you can go to bed?
All right. Hi, I'm Azna Ritchi. I'm a software engineer at Sourcegraph, and today I'm going to talk about my side project, which is Genji. Genji is an embedded database. It combines SQL with documents, and it's written in Go. So documents here are just any structured data, which could be flat or nested, or it's not limited to JSON type. In fact, Genji is not a JSON database. It's document fields are actually SQL types like ints, double, text, blobs, and so on. Genji took a different approach when it comes to SQL. Instead of implementing the SQL standard, we decided to treat documents as first-class citizens. So the SQL API is completely designed to take them into account, to deal with missing fields and type mismatch between documents, etc. So there's no JSON column type. There's no column. Concept of column. There are paths, which are very familiar if you look at these, and you have the choice between creating tables with schemaless tables or with schemas, and the schemas will allow you to control all the fields you care about. It's a general purpose database. You can use it for application data, for caching in memory or on disk. Exploring data you don't know much about. You can use it on small devices, on the web. Well, it's still experimental, but that's the goal. And you can store encrypted data on disk. So creating a table with a schema looks like this. It's pretty much the same as any other relational database. The main difference on the left, you can see that we are using paths instead of just columns. So you can see on line 18 that we are applying a constraint on the author name. And we also imply that author is a nested document, and it will be inferred automatically by the database. We can, as I said, use the constraint, any constraints we want, and we can also create indexes on either the fields we defined above or other fields that are not defined here. This is very important. Schemas in Genji only apply to what you care about, and the rest will be stored with the default conversion. We can also create schemaless database, as I said, by simply writing create table and the name of the table, and we'll be able to store anything. This could be very useful when we want flexibility, or we already know the shape of the data we are storing. So as an example, let's just consume the GitHub API and search issues from the Golang repository. So here's an example of a response from calling the GitHub API. So it's just a list of big JSON documents. So we'll start with creating a table called issue, and we will not define a schema for a constraint for all the fields. We know that there will not be changing because we're consuming the GitHub API in this case, and we are mostly interested in data exploration in this case. So all we want is to use the ID of each document and use it as the primary key, and make sure that it is an integer. Then we can create a structure or use one from the GitHub client library or whatever, just to unmarshal the JSON data into a Go structure. Then we can insert it by using insert into issue. And this one is let's say, the classic way of inserting data. We define a bunch of fields here, ID, URL, etc., and we just pass the values one by one. We can do better by just writing this, insert into issue values, and then we pass the complete variable. And Genji will use a little bit of reflection magic, not too much, to transform that structure into a document and then insert it and validate it if we defined any constraints. This is not implemented yet, but this is like a goal to be able to just specify the URL in place of the table, and the library will just go and fetch the data. I'm not sure it will support pagination, but gotta try it. Then once we fill the table with documents, we can query it. This is the Yankee API. You can use the query method to count the number of issues per user in the Go 119 milestone. And as you can see, we're using paths here, like where milestone.title equals Go 119. And yeah, we can use them in the group by in any classic SQL clause. It's pretty straightforward. We can, the query method returns a stream, and then we can iterate over the stream and just scan each document into the variable of our choice. In terms of features, we have update, delete, etc., and we are adding more and more. Joins are totally planned, not yet implemented at all, but we're getting there. We have ACID transactions. So this is a document database, but it has all of the guarantees that you can have with, let's say, SQLite, for example. So you have a single writer, concurrent writer, and multiple concurrent readers, and it's compatible with the database SQL package. It's written 100% in Go, so no CGO required. On the lower level, we are using an engine system. So we have 3 implementations. The first one is memory, so you can create an in-memory database with that. We're using the Google B3 library. And on disk, we have 2 flavors. One is Bolt.
Wow, thank you very much. That was an excellent talk. Some really interesting stuff there. I know I'm always looking for a good embedded SQL database, so I'm gonna have to give that a try out. So let's bring up our next speaker, Shawn. Shawn, are you with us?
Indeed I am. How you doing there, Mark?
All right, and yourself?
Yeah, good. I'm in sunny London. I mean, it's not sunny, it's winter and it's nighttime, but it could be sunny London, you know. It's if we say it off, nothing else can come true.
You do get those 2 or 3 days in August that really just make the rest of the year worthwhile.
Yeah, we call that summer. That's all of it. You know, the rest of it's
yeah.
you know, there's
I've been there once.
you know,
I've been there once in hot summer. It's lovely.
oh,
Anyway, why don't you let's hear what you have to say there, Shawn. Take it away.
Wonderful, thank you. So hi everyone, I'm Shawn. I'm the Senior Developer Advocate for the UK and Ireland at AWS. And I don't know about you, but I've seen a lot of slide text over the last couple of years. So today, I'm just going to talk just between you and I, but make it a bit more personal. So as a developer advocate, I spend a lot of time writing content and building demos to show off all the super cool stuff we build here for you at AWS. And with that in mind, whenever I put together a workshop or product, I like to include just a little bit of magic, just making things work as seamlessly or invisibly as possible so developers such as yourself can just enjoy what you're building rather than spending time fighting with bugs or struggling to figure out instructions. And this year at reInvent, which is our premier learning conference that we run for the global cloud computing community, I was involved in writing a workshop about migrations, getting your stack from wherever it is now up to AWS. And that would seem like a fairly straightforward proposition, right? Take thing in place A and put it in place B. Well, no. Anyone who's ever worked on a large-scale migration will tell you that it takes a whole bunch of planning, testing, and coordination to get something from place A to place B. And no 2 strategies are the same. There's almost incalculable number of AWS services and combinations of them that you can use to deploy your applications to. So how, when you're running these workshops, do you cover all the different use cases for as many people as possible without writing dozens or hundreds of specific niche workshops? Well, with a little bit of Go-powered magic, of course. See, first of all, when we were thinking about putting this workshop together, we needed a demo application that people could migrate from place A to place B. And we didn't want people to have to deal with example applications that would require installing dependencies and having to keep tracks of files across multiple locations. So things like Node.js with its Node modules or Python with pip, they're out. That's not part of the migration. That's a detail of the language. So having a single compiled binary was perfect for us. So Go was a very early, obvious choice. That said, having a server be a compiled binary doesn't completely help solve that if we have to deliver a directory of static assets that we want to serve through the application. So we wanted to build a HTTP server to demonstrate these things. So we just want one file, one application that has it all. So how do we achieve that? Well, there's this great module called go-bin data, which can take a directory and recursively convert the files therein to byte slices. And that means that all of our static assets are now built into the compile binary, and we can serve them from memory when the app is deployed. And so that's that. One tiny little magic app that you can pick up and deploy without having to worry about assets. But here's the rub. I mentioned we have a bunch of services that you can deploy applications to, and we planned to cover more than a couple of them in our workshop. You see, each service has its nuance and specificalities when it comes to running an application. So what works for one service out of the box may not work for the rest. Think Lambda versus EC2. It's a whole different mindset. And we're going to need an app that can detect where it is and behave appropriately instead of just firing up and hoping that it'll work. Now, it's easy enough to build something that goes, ta-da, you deployed me, well done you, woo! But that feels like a missed opportunity. We wanted to build something that would only tell you that you've done something right, but it will give you more information about what you had done. So how do we go about that? How do we build one app to rule them all and not immediately fall over when we hit an edge case? Well, that takes a little doing, but we figured it out. See, some services in AWS are kind enough to tell you when you're executing in their environment. Take Lambda and Fargate with ECS, for example. They set environment variables that you can look up and use to change things accordingly. Other services, however, like EC2, are a little bit trickier. See, EC2 doesn't set such an environment variable, but it does have the metadata service. And so the metadata service is an API which exists on your EC2 instances that you can query to find out information about the instance that you're running on. Things like instance name, public IP address, the AMI ID that was used to launch the instance. And so that's what we decided to do. First of all, we would check the environment variables to see if there were any services that we would recognize. If not, we then check for the presence of the metadata service by making a quick HTTP request. If the metadata service was there, we then do a follow-up request to get the instance type and check it was a valid value, rather than risk delivering a false positive to our users. So with environment variables and the metadata service, we've managed to cover our serverless platform, some of our container platforms, and EC2. And that's not everything, but it's a fairly big coverage of all the options we have to offer. But let's talk about Lambda. So you see, so far, our little magic application is a self-contained HTTP server, which, while very cool, isn't exactly the best thing to be serving up in a Lambda function. Lambda functions only run for the time that they're needed. So having an always-on, always-listening server makes no sense. So how do we get this thing to serve all the other use cases, but also feel at home in a serverless environment without bringing a load of bloat with it? And that's obvious, right? We make it create a new version of itself, specifically for Lambda. That's right. Our app can make a new version of itself prepared specifically for serverless environments. So how does that work? Well, if you think back, everything we need, all we need to do now is rearrange it. So if our workshop attendees hit the Lambda section of our Magic App webpage, we take all those dynamically generated views and render them for hosting from a secure S3 bucket. Then our code writes a new version of itself, which admittedly is in JavaScript. Sorry, everybody. That will let Lambda serve those assets from the S3 bucket out through an API gateway endpoint. And this all then gets put together in a zip archive, which is dynamically created and then sent as an octet stream to the requester. And all that can be done with just the click of a mouse. And that's it. That's how you build a magic app that knows where it is in AWS, changes how it acts depending on where it is, and even creates a new version of itself if it needs to. All in one handy, Go-compiled executable package. I've been Shawn Tracy. Thank you for your time. I'm big on feedback, so I believe there is going to be a link put in Discord any second now where you can tell me how I've done and let me know if you'd like to know anything more. So please do that. Otherwise, have fun. Thank you.
Thank you, Shawn. Make sure you get that sheet on the bed before the missus notices that it's gone. Okay. No, that was an excellent talk and very brave without any slides as well. I appreciate that. Let's bring up our next speaker. Christopher, you there?
I am here.
Fantastic. How you doing, Christopher?
I'm doing great. How are you?
Good, good, good. Christopher is one of my students this semester in my Intro to Go course, so it's always great to see my students coming through. So, of course, you are getting graded on this, so there's no pressure
Yeah.
at all. Christopher, where are you joining us from?
I'm in North Carolina.
North Carolina. Awesome. Well, take it away. Good luck.
All right. So today I'm going to be talking on a bit of a less technical, softer topic, but it's scratching your own itch using Go and XBAR. One of the reasons I'm talking about it is because building tools for yourself is rewarding, and it's also helpful. I'm not going to be getting deep into the details of XBAR, but their documentation is fairly strong, and I will describe the pieces that I show. So to start off, let's talk about why you're here. You initially probably decided to pick up Go, learn a little bit more about it, and you go the normal routes, read the books, all of the books, and now you're probably closer to a Go reference document or a scholar on the topic, but you may not actually be able to implement things yet. You just know about them out of context. You've watched video tutorials, and now you are fully capable of making the world's best to-do list or a Hello World web server. And you've probably read a lot of the written tutorials that are online. You've become extremely good at following line-by-line instructions, and your touch typing skills have much improved. But all jokes aside, all these resources are really great, and especially when you're getting started, it's a really great way to go. The people giving their time to create them do sacrifice their own personal time, and it's what makes the community so special. So having all these available allows people to learn. Everyone learns in different ways, and usually a combination of many. And then as you go, you need different things on top of that. So all of these provide a lot of different resources. So what I'm talking about today, if this sounds similar to you, is the plateau that you tend to hit after you've gotten through these and you're trying to move over to the next stage of getting prepared to start looking at entry-level positions or things like that. And a lot of what you hear is, we'll build things. Okay, so build things, but what do I build? And how do I decide, what direction to take it? And that's where XBAR comes in my opinion. What it is it's a application built by Matt Ryer that allows you to build and script things that appear in the Mac OS menu bar. It originally started off as Bitbar, made the top of Hacker News. And if you want to know more about the details, I know Matt has given a couple of talks and a lot of podcast interviews where he touches on it. He even says, this is an example from the site, and this is his quote on it. So from there, why XBAR? Well, the nice thing about XBAR is that it allows you to write these Go programs. You can do it compiled or scripted. And I'm just going to talk mainly about the compiled today. The scripted stuff, there's a couple of bugs related to writing Go in a script format. But it allows you to have an immediate feedback loop. You're going to be writing things that you are taking in as the user of. And so essentially you're dog fooding the code that you're writing, and you're going to be the best criticizer of that. And it hurts less when you're the critic of yourself. As an example, if you've ever looked at a line of code you've written, not knowing it was yours and asking who the heck wrote this, and then you type in git blame and realize it was you, it hurts a lot less than someone else giving you a hard time. So to get started quickly, you go to the docs on XBAR, you dutifully and academically pour through all of the details, or you just scan it quickly, find the piece you need, and start building things. And pay for it later when you get stuck. But the basics of it are this. You just print line out of your script, and it formats into this menu bar application. So the place that you start, obviously, would be just mapping the code, basic print line statements, to kind of see how this transfers into the output of the application. And here I have some more examples. As you go further down, these lines are just examples of different options that you have to try and play with different features in the application. This piece right here essentially gave me this in my menu bar. So it was just me testing how different things fall into place. The next step after this is clearly mischief. As developers, we tend to have the natural ability to want to use things in ways that they are not meant to be used and just see what's available. So this is an example. I just wanted to see if I stacked as much stuff as I could in the top part that was going to come out in the menu bar, what would happen? Would it overload the menu bar? Actually, no, it wouldn't. It animates through the items based on what's there, which is actually a really nice thing. Doing this, you kind of go through discovery. You figure and feel out how things work with this application. In this case, it would be a 30-second loop. Every one of these top 3 items would rotate every 10 seconds. So from here, the next stage would be free will. This is the point where you have the basics of the tool, and this is the part that's most important. You're going to have problems that you want to solve, and they're not going to be designated on, I want to learn A, B, and C. They're going to be designated on, I want to solve this problem. And what that's going to allow you to do is shove yourself into places that you're not comfortable with. It's going to allow you to come across things that are going to teach you why certain things are idiomatic in Go. And it's going to force you to learn, reference documentation, reference the language. So this is what I did. And parting thoughts, a personal example is Jira. We've all been there. It's not a bad tool, but sometimes, hypothetically, you work at a place that has a process that sounds like it's agile, mixed with waterfall, mixed with a 5-lane traffic jam, and a dumpster fire in the middle. But you need to make it work. So what you do is you build a tool that scrapes through the API, puts things in a neater format of how you can work with them, keeping the business happy because you're still accomplishing things, and allowing you to deliver on products as well. So then these are an example of a tool you would build. So the pieces are all in there. There's environment variables, there's API calls, calls up to shell, HTTP links, and on and on. And also, if you get bored from that, you can move over to Whales, which is what XBAR is built on. It allows you to build full applications. And at the end of it all, you get to learn. I wanted just to say thanks to Matt and Lee Anthony and all the open.
Thank you, Christopher. That was excellent. I particularly loved when you almost attributed XBAR to me. I'm sure Matt will love that. Nice little Matt Freudian slip there. So thank you very much for that. I truly enjoyed that. Let's bring up the next guest here. I believe we have Varun with us next.
Hello.
Hey, Varun, how are you doing?
I'm doing great. Yeah,
Excellent. Where
what
are you
about
joining
you?
us from? I'm doing great. It's GopherCon. It's GopherCon. Who
Yeah,
doesn't
I'm
love
joining from
GopherCon?
Mumbai. Yeah,
Mumbai. Oh, from
yeah.
wow. So from quite a way. So it's
It's
also
nearly
even later
midnight.
for
Yeah.
you than it was for Amit. Nice. Have you ever been to a GopherCon before?
No, this is my first GopherCon, so I'm really excited
Oh,
to be here.
welcome. Well, hopefully you get to join us in person. They're super cool in person. I mean, this is
Mm-hmm.
cool.
Mm-hmm.
Super cooler in person, trust me. Anyway,
Mm-hmm.
you are going to be talking about better understanding of errors, right?
Uh-huh. Yeah.
Fantastic. We all need to understand our errors better. So take it away. Let's hear from you, Varun.
Mm-hmm. Hey everyone, I'm Varun Gandhi. I work as a software engineer at SourceGraph. I've only been writing Go for about 6 weeks now, after working in C++ for about 2.5 years. Given that, the compiler complains about my code quite a bit. So today, I want to share my favorite tip for better understanding compiler error messages, which is by reading the Go spec. So what is the Go spec? It is a document describing the syntax and semantics of Go code. Syntax covers things like keywords, punctuation, and so on. Semantics covers type checking and the runtime behavior of code. Unlike some other language specs, such as that for C++, the Go spec is quite accessible. If you're not sure why some code does or does not lead to a compiler error, then consulting the spec is a good way to understand the details. Let me illustrate with a couple of simplified examples based on actual errors I was having trouble understanding. Consider the following example code. I've declared a struct x with a single string field s, and I'm trying to get a pointer to the field in various ways in the function f. Which of these lines do you think will result in a compiler error? I will wait for 10 seconds in case you want to think about it before I reveal the answer. Turns out the fourth line in the function will give an error, but the other lines are okay. For the fourth line, the compiler complains that you can't take the address of i.x.s, but it doesn't say why you can't do that. Clearly, there's some reason why taking the address is allowed on the second and third lines, but not on the fourth line. Let's take a look at the spec to understand this better. In the Go spec, there's a section called Address Operators, which covers this. I've slightly tweaked the wording in that section and shown it here. According to the spec, the address of x is only well defined if x falls into one of the 5 cases described here. It's a variable, a pointer, a field access, or a slice or array indexing operation. Let me remove those last 2, since those won't be relevant for us. Now let's see how this definition applies to the code example from before. The relevant case is the field selector one, since in all 3 cases, we're trying to take the address of a field. So what exactly is the addressable struct operand part? We can answer that recursively by examining the definition of addressable again. Temp is addressable because it is a variable. Hence, temp.s is the field selector of an addressable struct operand, and it too is addressable. i.x is a pointer in direction, hence it is addressable. Hence, i.x.s is also addressable, because it is the field selector of an addressable struct operand. However, in the last case, i.x is neither a variable nor a pointer nor a field selector. Since it doesn't match any of the cases, we're forced to conclude that i.x is not addressable. Hence, i.x.s is also not addressable. That's why the compiler gave us an error for the last case, stating that we couldn't take the address of i.x.s. Okay, that's a lot, but now let's move on to a different example. Here's a trick question. Does Go have implicit conversions where it would convert a value of one type to a value of a different type without an explicit cast operation? If you ask a search engine, it might give you a confident result, saying that Go doesn't really have implicit conversions. Again, this is an example where consulting the specification is valuable. Let's consider some code as shown here. I have 2 custom types, A and B, which are wrappers over a struct and string respectively. I take a value of the custom type and try to return it as a different type, first for A and then for B. Take 10 seconds. Which of these do you think will work? Turns out the first function works and the second function doesn't. The compiler tells us that you can't use B as type string, but it's not clear why the example with A works, but the example with B doesn't. They seem pretty similar, right? Again, let's look at the spec to see if it can help us better understand what's going on here. In this case, since the error is in type checking a return statement, let's look at that section. According to the section on return statements, the condition that applies here is that the return value must be assignable to the function's result type. Assignable here is a key term that is defined in the spec. Let's look at its definition. There are many different cases for when some variable is assignable to a type T, but the case that is relevant here is the one that talks about identical underlying types. Here, underlying type and defined types are also terms which are defined in the spec. I'm not going to show you their definitions because there's only so much space on the slide, but I will explain them in context as we go along. Let's look at how this applies to the first code example from before. For the example of the single element struct, the underlying type of A is the single element struct type, and the struct's underlying type is itself. You can think of the underlying type as what's on the right-hand side of a definition for types which are defined with type declarations. So B and T will have identical underlying types, and the first condition is satisfied. If you look at the second condition, A is a defined type, but according to the spec, an anonymous struct type is not a defined type because there's no type declaration for it. Hence, the second condition. Let's look at the second example. The underlying type of B is string, and string's underlying type is itself. So again, the first condition is satisfied. However, according to the spec, both B and string are defined types, so the second condition is not satisfied. And that's why we got that compiler error. I just want to leave you with a couple of closing thoughts. If a compiler error doesn't make sense, your first instinct may be to use Google or Stack Overflow. To that list, consider adding the spec as well, because if you put in a little bit of extra work, you'll get a much more authoritative answer. Second, sometimes reading the spec can help you understand the different cases in the language, which you hadn't considered before. Thanks for your time. If you want to learn about how SourceGraph can help you understand your code faster, check out this QR code. And if you're passionate about spreading code literacy, join our community space. I look forward to speaking with all of you in Discord or on Twitter. Thanks.
Well, thank you, Varun. That was fantastic. I really enjoyed that talk very much. And agree, you should read the Go spec. It does hold most of the answers. So definitely great advice on reading that spec. So with that said, we have time for one more excellent speaker here. I mean, it's been just an amazing slate of speakers, like I said. So let's bring up our next speaker. Kevin, are you with us?
Hello.
Hey, Kevin, can you hear me?
Yes, I can.
Fantastic. And where are you joining us from?
I'm joining you from Uganda.
From
Kampala.
Uganda. Okay.
Exotic locations.
Fantastic. Okay, well, why don't you take it away here? I'd love to hear from you. Go for it.
Okay, so I'm Kevin. I've been a software developer for a couple of years. I'm new to Go actually. This is my first year of using Go, tinkering with it. I did a small workshop earlier that really made me fall in love with the language, the simplicity, and the way it's used, and generally the community also. Today I wanted to talk about making an image recognition application that could determine the age of a bean plant. Since we can use machine learning models to extract information from images, I was thinking that I could just build a small app that would get, let me say, size information from the length of the leaf or something, and then I could determine how long that plant has been up. That was my original plan, and then I ended up discovering that that was not going to be so simple, and there's a lot of technical debt and technical understanding that goes into trying to create something like this. So today I wanted instead to highlight some of the issues or the technologies that a person would have to focus on if trying to develop, say, an image recognition application, so that I can help also other beginner users actually get something done instead of spending all of their time researching different issues. So instead of sharing a slide, I'll be sharing an article that I landed on that I feel covers all of the technical issues that one would face in the process. Let me start with sharing the TensorFlow guides themselves. Anyone who has tried to look through the documentation for TensorFlow has seen that the Go bindings are extremely difficult to understand and to interpret in a quick sense. It's not easy for someone to just pick up the technology and, let me say, add the adapters and use them to create, to process the information. Yes, because when you start in this process, you imagine you're just going to build them, say, as an API service that will receive information, pass that information, pass the image information, and then return that. The article that I landed on that helped me outline this entire process is API building an API recognition with Go and TensorFlow by Tin Rabzej. I don't want to say. I hope I'm not saying that so badly. In the basic sense, we're going to look at getting the image, the response. Okay, let me say the request response, passing the data, and feeding the tensor model to the machine learning model, and then returning some output. One of the first technologies that the person has to understand before even they dive into this is Docker, because since you're going to be running machine learning models, you're going to have to run some sort of orchestrated container to host both the application and the machine models that you're going to be running. So here he easily quickly describes the Docker compose file, load some TensorFlow. I'm not going to dive into details because it's a limited talk, and the more I looked into it, the more I realized that I cannot go into depth about some of the concepts that I wanted to cover. He extracts the Docker image from the official repository, and then let's dive into the necessary packages for Go. Here I also want to take a side note to outline that I feel there's a steep, okay, not a steep, but there's a learning curve involved before you work with anything that is machine learning related. It's not plug and play like you'd imagine with many libraries. As a software developer, we get used, I think we get accustomed to being able to look into something, pick up a new technology, research it a bit, and then start tinkering around. The first, after the step of learning Docker, the next step you have to go to is learning, let me say, how to implement machine learning models. So what you get from a model usually is a graph that understands the image layers of the data, and then a list of labels that is used to, and to, let me say, for the output, to give you the response of what you're looking for and what is going to be predicted from the image layers. Let me dive directly into the model here. When you load the model here, you can see that an understanding of Go is not enough to be, let me say, to develop the. That is quick. You have to get the image response, pass that to the model through the handler from your server, the HTTP server, and then send back the bytecode, the byte response. Images are another obstacle that you realize when working with images is that they do not allow you to add the data directly. You usually have to undergo some sort of transformation such that the machine learning model can understand the kind of data you're trying to feed it. I'll look at that here. I don't really think there's enough.
Well, thank you, Kevin. That was wonderful. Now, look, I know I said Kevin was going to be our last speaker. But you know me. I don't play by anybody's rules. I'm Mark Bates. I'm going to give you one more talk. What? That's right, one more talk. Let's bring up Arun and Yankee. Arun, Yankee, how are you two doing?
Very well.
Yeah, doing great.
We're
Excellent.
ready to go.
Great. And you're, Arun, where are you joining us from?
I'm coming from Berlin. We had our first proper day of snowing, so Christmas is on the way.
Fantastic. And Yankee, where are you coming from?
I'm from Kathmandu, Nepal. So it's currently midnight.
Fantastic.
Excited to join GopherCon. Yeah.
I'm excited to hear what the two of you have to say. So take it away. Go for it.
Yeah. Hi, everyone. So, if we could map out Go, we are here today in order to expand that map a little bit by introducing you to the community of Go developers from the Himalayan country of Nepal. So let's go to Nepal. So for anybody that doesn't know where exactly Nepal is, if you see this map and you can spot the gopher, then you found Nepal. So Go Nepal is a small but a growing community. We are roughly, reaching the target of roughly around 200 developers and more at the moment. We started with 2019. I'm actually very new to it, but that's the reason why we have Yankee here in order to give you a bit more insight on that. And before we get into the meat of it, we want to introduce you to our gopher as well, the one that you see right over there wearing the Nepali topi and the Daura Surwal, which is our national dress. So that's our mascot. So let me introduce Yankee.
Yeah, Yankee from Postpay, basically. Yep.
And we also wanted to make sure that we included Milap Neopane, who is also from Go Nepal team. He's one of the early founders, so we wanted to make sure that he was put on the slide because he's provided us with a lot of information. So Yankee, why don't you cover us on how things are going with the state of Go in Nepal at the moment?
Yeah, so like Arun mentioned, Go is like pretty popular here in Nepal. So uh, in our Go community, we have a lot of early adapters since the early days of Go. We have a lot of CS students who are like coming into our meetups, learning new things. And we also have a professional crowd of software developers, and it's pretty popular among DevOps in Nepal as well. So what is Go used for? Mostly for internal tools and open source contributions. So we have a huge pool of people contributing to open source projects in the CNCF space. So that's pretty cool. And we have a lot of enthusiasts doing a lot of cool things with Go. And on the right, you can see the screenshot of one of our meetups where we had the privilege of having Bill Kennedy to talk about the generics in Go. So, having said that, let's go to the next slide and look at our past events. So, we have had a great track record when it comes to our events. We have the likes of Bill Kennedy, and we have Isan Mukherjee and Zain Askar talking about Pixie. If you are into the Kubernetes space and uh, for observability stuffs, like Pixie is great. And yeah, although we have been in this space for a pretty short time, but we have had great leaders from the Go community come to our community, expand it, make it more knowledgeable. And yeah, it's pretty exciting. Next. So our experience so far, for every growing community, you need a positive feedback loop. So the first point talks about virtuous cycle, where we have like enthusiast people in the community who inspires the next generation, and the same cycle repeats so that we have a budding and thriving community of Go developers. And also one of the experiences we have had on our meetups is like market needs sometimes expects personal drive. So this is pre-pandemic, so maybe next year when we come things might change. But yeah, uh, the Nepali market is used for JavaScript developers, so the Go is like on the rise, I would say. But since international companies are opening up for jobs, so it's going to be a different scene next year. And also we need more push for open source software, although I have mentioned like there are a lot of contributors, but I think it's not enough, right? So that's where you guys come in. Next slide, please. Yeah, so that was our community, and we invite you to join us. If you want to showcase your tools and techniques, if you want to talk about design patterns, if you want to talk about industry standards, or some open source projects you are like passionate about, you're contributing to, or you're founder of, so we will be pleased to have you in our community. We will provide you the platform. We have a very thriving audience that is seeking to get the knowledge out of all of this. So yeah, if you want to join our community, we have the meetup link down below, so you can just go to that link and be part of it, and we can talk, join the discussion, what we can do together as a community for the community. uh, yeah, Arun, you're up.
For me, I'm also a beginner myself, and I'm only starting with my Go journey now. But to be able to have the representation for Go Nepal here with GopherCon for the first time, it's absolutely great. We really want to thank GopherCon, and especially thank Mark Bates, because of his lightning talks. A small voices just like ours has a chance to just come out to the big worldwide space. So we thank Mark, we thank GopherCon, and hopefully the next time you are going to be seeing us is actually going to be in an event that is organized by Go Nepal. So we are there. We are trying to get out there as well, and we look forward to you in our next events. Thank you again, and Dhanyavad, which actually means thank you in Nepali. So that was us, and we hope to see you next time.
Thank you, fellas. I really appreciate that. Speakers, please hit them up for talks. I'm sure, like all good meetups, they're looking for great talks. And I know I'm very excited to someday be flown business class to Nepal to speak at GopherCon Nepal when they have it. With that said, that's all we have for time for today. We got a great lineup of 8 talks tomorrow. Join us at the same time, and we're going to throw it back to the studio for more great content.